Now the next example we're going to consider will illustrate another special case that we may encounter when solving a system of three equations and three unknowns. Now let's suppose for the system that you can see written here that we'd like to use elimination, and I'm going to choose to eliminate the x variable. And let's do that first using equations 1 and 2. And I think you can see if I multiply equation 1 by 3 and add it to equation 2 that the x terms would drop out. So if we multiply equation 1 by 3, you can see written in blue here that we're going to have 3x minus 3y plus 3z is equal to 12. And putting equation 2 underneath that, and then adding the two equations together, you can see that we'll end up then with 0. All the variable terms drop out is equal to 0, which you know we can label as being an identity. Now essentially what this will tell us is that equations 1 and 2 represent the same graph or the same plane. So there are infinitely many solutions using equations 1 and 2. Now let's next eliminate x using equations 1 and 3. So multiplying equation 1 by negative 2, you can see that we're going to have negative 2x plus 2y minus 2z is equal to negative 8. And if we add that to equation 3, listed below that, we again see that all the variable terms drop out. We end up with 0 then is equal to 0, which is another identity. So that will tell us then that equations 1 and 3 represent the same graph. So in essence then what we've shown here is that all three equations represent the same plane. So there would be infinitely many points in common. And so we can label this system as then as being dependent and consistent. And then the best way to represent the solution here would be to say we want all the points that lie on one of those planes. And so we'll need to use set builder notation to do that. So we can then write the following. We want all ordered triples x, y, and z that lie on one of the planes, and let's say I'm going to choose equation 1 here, so it'd be x minus y plus z then is equal to 4. So again what we've shown is that all three planes are really the same, they're the same graph, and the solution then would consist of all the points lying on one of those planes.